Today we're going to talk about how to take the inverse of a function. What does that mean geometrically, like looking at a graph to take the inverse of a function, and algebraically, how do we find the inverse of a function? Well, before we can do that, we have to go back to our definition of a relation. Hopefully you remember what a relation is. It is a mapping of input values onto output values. So if you look at this example here, let's say I give you a table of values. This is your input, your x, your domain values. This is your output. So I'm doing some rule to my input values x to get my output values y. Well, what the inverse relation is and does is it maps the output values back to their original input values. So if I'm looking at the inverse relation of this original relation, you should notice that the input values are your output values for the inverse, and your output values of your original relation are the input values of your inverse. So that means the domain of the inverse relation is the range of the original relation, and the range of your inverse relation is the domain of the original relation. So we've just kind of interchanged the x and the y values. Now, what is the graph of an inverse relation look like? Graph of the inverse relation. Well, if you were to plot these original points, you'd get one graph, and once you interchange the x and the y values and you plot those corresponding points, what you will notice is that you get the reflection of the original. So the inverse is a reflection of the original relation across the line y equal x. So this is very fascinating, and we'll have to do the activity together. I wanted you to do a discovery activity to discover what it is graphically, but we can do that later since I'm not there. So algebraically, what is the definition of an inverse of a function? So the definition, if f and g are two functions, such that if we take the composition f composed with g, and we take the composition g composed with f, so we're taking the composition in both directions, that both of those will equal x for every x in the domain of g and in the domain of f. So that is how you would verify that two functions are inverses of each other. Two functions are inverses of each other if and only if taking the composition in both directions give you the same thing, and the same thing that you get is x. So how do we represent taking the inverse of a function? Well, if you have the function g and it is the inverse of the function f, you represent that as f with a superscript of -1. And you read that as f inverse. So this notation here is just read as f inverse. So you're taking the inverse of f. So f composed with itself, and this is missing a little close parentheses, f composed with its inverse is x, and f inverse composed with f is x. So the domain of f is equal to the range of f inverse and vice versa. So hopefully you're recognizing that. So as we just said, to verify functions are inverses of each other, you have to take the composition in both directions. So you'd have to take f of g of x and g of f of x, and you would need to show that they both equal x. So let's go ahead and do that. You have two functions. You have f of x and you have g of x. So I'm going to compute the composition of those two functions in both order. So remember, you work from the outside in. So I'm going to begin with f of x, since f is on the outside, which is 3x plus 2. And what am I going to substitute in for x in my outside function f? I'm going to substitute in g. So now I'm going to substitute in g for x. So I'm taking f of g of x, and that would be 3 times, we said x is g of x, and this is g of x, so that would be x minus 2 over 3 plus 2. So if I look at the right-hand side of that equation, I can simplify. And that is going to give me x minus 2 plus 2, which is just x. So I have shown that f composed with g, with respect to x, is in fact x. That's not enough to prove that the two are inverses of each other, because we still have to take the composition in the other direction. So now I'm going to start with my outside function, g of x. So g of x is x minus 2 over 3. And I'm going to input into that function f of x. So I'm going to now substitute in f of x for x. So I have g of f of x. And again, I'm going to substitute in for x f of x. So I have 3